Hello, hello. All right, so right now, this is the power supply. Make sure we got everything in the shot here. All right, yeah, this right here is the power supply. I'm planning on changing that to the cat bank. So the cat bank is basically going to be the beginning and the end. And then we're going to have one of these in between each circuit. We're going to have two motors. So hopefully it will recognize it as being two different motors. I don't think it will, but maybe it will. In which case one could give energy to the other without there being a problem. But since it's probably gonna, we'll see what happens. Because we're gonna switch it to this. Cat bank is the power supply. And then we're gonna put these ends. Again, I gotta make sure it's all in there. Yeah, it looks like it is. All right, so we're gonna put the ends of this cat bank. First, let's see if it's gonna light up. Yeah, it looks like it's, well, it doesn't look like it's working right now. And it could be the transistor. It doesn't like it when I shut it off. There it goes. It's a loose connection, man. That's weak. Okay, so it's like 34. Okay, that's more like it. Probably turn this down a little bit. There we go. All right. I have a feeling this will work just fine. I mean, it is with this power. Yeah, we went from like 40 volts in the cat bank to 80, like that, because it started running. Yeah, bad connections have been kind of what it's been like. But, all right, so I'm just kind of I'm going to put directional diodes so everything, it's going in a definite direction. All right. All right, so I'm gonna use one of these big ones, 3 amps, 1,000 volts. All right. Let's put that down. Space, the final frontier. It is definitely a short supply right now. The negative terminal is going to be a pain in the butt. See, now this is the negative terminal is also quite, I said, I don't even think I need a diode for the negative terminal. But, and then if I do use a diode, which way is it going? Which way is it going to face? I'm not sure. I think it's this way. And if it isn't this way, it won't do anything, so. I honestly have no idea about this one. I think we're going to do it like this. Yeah, we're going to do it like this. Well, that might work. No. Oh, I see. I see. This meter is reading what's in the cat bank when I do that. How about now? What about this one? How about this one. Okay, so can't really tell. Except that one that I did right here where there's no diode. Just clip it on both on the same side. Yeah, I think this might work. All right. So we're going to go no diode, but we have a diode there in case we want to put it in there. Now we're going to run this just to see if we're charging and the energy is going all the way through. Oh, I didn't put a meter on the cat bank, the big one, so I got to do that. Looks like it's about to fall off. I hope it doesn't fall. We're not getting a charge on the cat bank though, so it doesn't look like this theory is going to fly. Unless we can find, I think it's still a loose connection though. Oh, it is charging. or you know, it can charge. Sweet. It's at 7.4, it's at 7.5 now, but it's like there's a bad connection that I gotta take care of. Man, that would be sweet. That would be so cool to have the energy be drawn from the cat bank to run this motor, which would produce or unveil the electricity for this cat bank, and then it would then go into this motor, and then from this motor go back into the big cat bank, which started the whole thing. So it's not like a figure eight quite, but it's more like just a loop. If we can get all the stuff to work the way it's supposed to. It's just like it to have, you know, an issue right now. Wow, that's interesting. Yeah, it's not charging, that's for sure. Um, huh. Wonder if I use just a rectifier diode instead of a cat bank. No. There's like bridge rectifiers in the cat bank, so that's overkill. All right, so we got an AC side, and the energy that's going into the AC side is being picked up off of the beginning of this coil and the end of this coil, this one right here. And I'm sure it's just a bad connection somewhere, but doesn't seem that no matter what I do now, it's not working. So wish I had another one. Because it works, like spontaneously, it'll turn on. we're gonna work on it. I do have another motor to play with, but I want to see if this can even like function for a little bit, but it doesn't seem that like all my components aren't right. They're not right. That's all right. I'm looking for one of two things. I'm either looking for these lights to turn on, or I'm looking for the number of the value of the voltage of the cap bank to go up. And neither one of those things are happening. Which is again okay. I think it's right here, which would suck because I don't think I have another one of these. No, that's not running. No, that's kind of. Oh, there's my kid. All right. Paige. Hi. All right, I'm gonna try something. All right. All right, let's try that. Hmm. I don't know. Is it working? I mean, it could be working, and I'm just so used to it going much faster. Yes, we're charging. Sweet. But I'm just waiting for it to spontaneously turn off. Yes, yes. Woo! Not the fastest thing in the world, but that's the objective, to have all that energy go back into the cat bank. And that's the end right now. That cat bank is like the ground of the circuit, kind of. It's not the ground for the power yet. It will be. Oh, that's so cool. But we are drawing like 430 milliamps. So it's not going to last long, if it lasts at all. Or it'll be a lot slower. It might last longer if it's slower. I don't know. It's all mathematical as to how long it's going to last, really. So that's awesome. And this is the cat big is charging now. So I'm going to do this. I'm going to turn this off. But now there's no diodes on it. There's no diodes. They're all sleeping right now. So I don't think it'll connect. I don't know. It's got to go through a lot of stuff, but I think it's all still on the same path. All right. Maybe we turn it. See, in my mind, I just connected, but I think maybe, maybe we just connected. Oh, all right. So that would mean we unhook from the power supply. Oh. All right, sweet. Sweet. Now, what about if we connect them both at the same time? I don't know. Have to connect these somewhere else. 7.5. I don't know. We'll see what happens. We got action in the cat bank though. It's flashing. Not so much over here though. So I think if I had it juiced up like to 10 volts or maybe 12 volts instead of 7.8, this would go for a while. If this thing over here is working, I don't know if it's working or not. Like, here, let's try moving this over a little bit. $7.1. I believe that's right. Wow, that's actually pretty good if it was enough to keep it running. But I've noticed that it doesn't really get going that well until I get it up to about 7 or 8, 9 volts with this much copper in the system. 6.9. Six 6.7. Oh, we can drop it down. 6.75. Nice. 7.4, 7.3. So it's definitely spending. I'm pretty sure it can pick up too. It's just which one is more. But and if this cat bank is in any way like not having energy flow through it, that would also be an issue. So we'll spin this one first this time. You know, the connections are right. I just, yeah. I don't see any fluctuation in the light here, so I don't think it's like pulsing through. Our meter reading is giving us this cat bank's voltage, so that's why I have the meter over there. Oh man. No, I know the rules, man. I know that this isn't gonna like run itself. I know that. Doesn't mean I can't mess around, dude. Does not mean that at all. Got all this stuff. Might as well try and mess around with it a little bit. I wonder. Just messing around with the diodes again. It's fun though. It's fun to see like how fast it happens, um, and other things. You know, like the different variations of. Hey, hey, turn it off. Turn off mine. I gotta go. No, turn off my phone. No, no.
What's on?
I'll be in here with some people for a second. I gotta go.
What?
Yes.
Where? What's going on? Oh. Wait, end it?
Sure.
Or just take cover for a little while?
Yeah, cover it.
Alright. Hi, people. So, does anybody know what we have going on here? I kind of just got here. Hi, kitty. Oh, okay. Nice profile picture, by the way. Hmm. Okay, so from what I've heard, I think this is like a pulse motor, and it like spins. I don't know much about magnets, um, but I believe it like spins using like magnetic force from like the magnets on it, and that just kind of keeps going in a circle. And then all the wires, I'm not really sure about. But yeah, um, I'm assuming these can power things like lights when they're going and connected to wires and stuff. From what I've seen, there's also been like a ton of things that have happened in the past where like yeah, there's accidents when you do this stuff. So, yeah, magnets have like accidentally came off or like it's gone a little too fast and just kind of like shook the table and that's not fun. Or since we have the cat in here, he likes to jump up and bite things and we don't like that. But okay. 5.22 volts, whatever that means. Does anybody here know what voltage means? Okay. Yeah, I always hear that word getting like thrown around and I was never really sure of it. But yeah, that makes sense. I used to be on this channel quite a bit, but then I kind of just stopped coming on. There were like some friends and, some people that were also featured on here that I kind of knew a little bit. Uh, but that was a while ago. I don't know if those lives are still up or if they've been privated, but yeah. I used to be on here all the time. I used to help Papa Bale out with the kind of show thing, I suppose. Um, I wanted to become an editor for him at one point, but decided not to because I don't really have the time for that. Googled the answer because he's a simp. I don't think that makes him a simp. Oh, Google is very nice though. I would definitely choose Google over Chat GPT, in my honest opinion. I don't know. I feel like Google, I'm so used to clicking on it instead of going to ChatGPT that it's just whenever I need like an answer and it's run by like the same little AI thing. So like if you type something into ChatGPT, it would give you an AI response, and then if you type something into Google, it would give you an AI response. So I feel like they're not really that, far away from each other, even though Google is like more of a search engine where you can like go on to different things, but ChatGPT is just, well, it's ChatGPT. Paper clips. Anyways. Some different things. I haven't been on here in a little while, so I don't really, the setup used to be a lot more different than this, and I remember, um, there was a lot more stuff that looked like this instead of that, and everything is kind of different now, and I'm kind of still exploring. I remember one thing. Oh, this, which I don't know if this can still be like ran anywhere, but this magnetic ball would kind of spin around in here and kind of like jump up a little bit, which is kind of dangerous, I guess, because the ball it does have a little bit of weight to it, and it's, kind of fast. But it would spin around a lot, and you can see in here that, some of it kind of rubbed off onto the plastic from the 3D printer. What else do we got here? And for anyone who's like just joining in, I'm not the owner of the show. I'm just filling in because Papa Bale's gone right now. He's doing something. But okay.
All right.
Welcome back.
Thank you. Did you spin them?
Yeah.
Good. All right.
Knuckle cracking. That feels good. Okay.
Thank you.
You're welcome.
All right, so I've decided to do something else, which is okay. Gotta make sure that thing's working right. And my prediction is that it will slowly deplete energy from the cat bank. And that's the answer. That's what's going to happen. Little kitty. All right. All right. So this is like what I'm also working on right now. This is an Utron. It's a upside down cone, or depending on how you look at it, the pointy side down, that half. You can get another one of these, put it on top, with the pointy side facing up, and there's your thing. Alright, now I need to get, yeah, that's north. So we go here, north. And you get it basically in the middle. And we can, you know, perfect the positioning after we put it on. Yes. Yes.
That?
Yeah.
Yeah. Spin it.
Make sure it's still working right. And then we get the electromagnetic rotor. Everybody seems to hate this, or think it's really cool, but not know what to do with it. Like, what is it? See, this is...
Time machine.
Yeah, that's it. Without a doubt, it has to be a time machine. Alright, so we put this. As long as nothing got knocked out, it should be all we need to do. Alright, so we got a counter rotation. Not a real one. Let's get a real one going. So we got 3 neos at 120 on the outside and 1 coil on the inside. Now the way I think about it is that these interact with the environment, right? Magnetism interacts with the environment. I've come up with a way to make this stop without me using my fingers. It involves an SSR and an IR induced SSR relay. So like using infrared to trigger an SSR. Boom. That's how we're going to do it. Because, yeah. Don't even put my finger in there anymore. Put 2. We're going to do 2 drives real quick. I think somebody related this to a dead frog trying to come back to life or something.
Whoa.
I don't know.
I mean, I think it could with the amount of electricity in it. I feel like those could power, those things that, like, bring people's hearts back to life.
A defibrillator?
Yes.
Defibrillator?
Something like that.
Yeah. So yeah, man, it's and like people have been like, what was it for? What does it do? I mean, well, you can hook things up to the rotor and it'll make them spin, like propeller blades, you know. And this isn't to scale. The cool thing about all of this stuff is that it's scalable through the mathematics.
Mm-hmm.
It's so scalable. I mean, some of it is not scalable, but this for sure, you could scale this up big time.
If you had all the right stuff for it, you could make like a mini helicopter.
Yeah, or like you could, yeah, the mini helicopter that is in your wheel well.
Yes.
Yes.
You could do anything with it, really. You could make a fan. You could maybe even power like a light. Well, you can.
You can definitely power the lights. It's getting the readings that I've had a hard problem with. Like I can't hook one of my meters up to it because it's moving. And if you hook a meter up to it, it'll just like maybe a slip ring mechanism that has a really high RPM rating. Wow, the momentum on that thing it's a lot. It's great though, because that's all I'm really looking for is to make it spin. All that other stuff sold separately. Yeah, you know what I'm saying? It's like if you want the rubber hand for the Spankatron 9000.
The Spankatron. See, you could really make anything out of something like this.
Right. You know, you just need the attachments.
Yeah. There's endless possibilities with something like this. It's just fun and games. I bet you could make a time machine out of it if you really tried.
Back to how this interacts with the environment. When normal motors have the neos spinning, neo is the part that's spinning, electromagnet is stator, right?
Mm-hmm.
And in that way, well, that's the way it normally is. That way you can get readings, and it makes sense, right?
Yes.
And now, what I've done is I've taken the stator and I put it on the rotor. And the only way you can do that is to put the circuitry, the coil, and the power on the rotor. And it's not hard once you know what you gotta, the components you need. And you can home make the whole thing, What I'm trying to do though is get a solid state relay that's IR triggered and have this thing like be able to be turned off by remote, so I don't have to keep putting my finger in there. Yeah, man, that's going to be important for me. Yeah, that's going to be a learning experience, but it seems like a pretty simple circuit, and just need to, and then it'll be remote controlled. That'll be great. That was the objective from the start, to have it be turned off in that way. All right. I've been doing a little bit of experimenting with 16 gauge. It's powerful, but the trigger in this coil is 26 gauge, and it only hits sometimes with the big square magnet. And I was going to run cubes on it. The cubes won't even make it work. And I know it sounds like you're doing something wrong. Yeah, I'm pretty sure I am, but it doesn't have anything to do with this. It's just that it's too short. It's like 90 turns of 26 gauge, and it's got to generate 0.5 of a volt to make the MPN fire. So what I do is I hook all these in series, and I use, where is that thing? Right here. I use an external trigger coil. So, and then that drops the amps that requires to run down a bunch, having it go to the 26 gauge as well. Reduces that cost by about 400 milliamps. And because 16 gauge just eats the amps, man, it requires a lot of amps to run. Now the cool thing about it is that I was doing some tests yesterday with the oscilloscope, and all the readings were higher than what I was putting into the system. I think that's typical for an oscilloscope. but for the first time I was getting amps. And let me show you what coil I was using. I got about 250 milliamps off of magnetic induction off of this coil right here. And there's literally like total like 20,000 turns of 20, 28, 30, and 32 gauge. This is an awesome coil, but it needs to be improved, man. I had a bunch of spools that were almost gone, and I combined them into this coil. Is basically what happened, because there's like 2,000 turns of 32 that I can't use. I'm really mad, but one of the 32 gauge ends broke, so all I have is 30 and 28. But you know, I got over 15,000 turns of both of those. This coil weighs 2.2 pounds. It's awesome for, you know, in my opinion. I usually work with 32 gauge, and I never get more than 20 milliamps. So to see 250 on the screen just from it being connected to the coil, it was like, wow, okay, maybe we should rethink being so thin in the pickup coil, and like make some, maybe some parallel coils, different gauges, and yeah, there's actually subtle differences in having your gauge be different, because, you know, with current limiting, you're going to go with the current of the thinnest, and then with the voltage, and then the length, it's all different. It's great. You want to get your mind off stuff? Make a multi-filer coil with all different gauges. It's awesome. It really is, especially with 32, because you end up getting like 300 volts, but only 20 milliamps. So you put the 26 in there as well, and I don't know what the effect would be, because right now I'm just using 20, 28, and 30, and I haven't separated them or tried to see anything different. You know, like I had it hooked in series, and I still do. Just imagine 6 nails in here, how fast it'd be picking up. Man, it feels like it would run away. If I let it, it would like get to a point where I wouldn't be able to stop it with my hand at all. Like, don't touch it. And then I don't want it to get to that point, because I literally don't have a way to turn it off until I do that circuit that I'm planning on doing maybe later tonight, or as soon as I get the components. So it's a little solid state relay that would be triggered by an IR switch and remote control, basically. And that's exactly what I was trying to get at, you know. I want to be able to, you know, point my remote control at it and turn it on and off. So cool. Now, this is, like I said, it was supposed to have a top to it. I might have to re-engineer completely the rotor, make it a lot smaller, north and south wise, or up and down wise. You can see why. Is this is the top part of the Utron, and it will, as you work the angle up, cut off some stuff. So we're trying to get it, down in there and eliminate all this stuff that's sticking out of the top, and then we'll build the rest of the cone. That'll be awesome. I think the batteries are getting a little low. They're lithium ion, so all I gotta do is unplug them and plug in my charger. Oh wow, that's so neat. Kind of feels like a top, doesn't it? Like, and even later you completed it, like it would go out like this, and up like that, but it's big, so it's not like you would work it like a top. It would just look like one. Because the idea is to have it spin, and then like to have this mechanism inside of it, it would spin and spin pretty fast. All right, I want to go get you what motivated um, some of this. Mm. All right. I gotta get top. Are you editing?
Mhm.
Awesome. All right, there is one other thing that I did want to check out. It's another one of the kind of rotating devices. Anyway, this is the top that I built. And it's got 10 millimeter neos in it. I think 10 of them. And then I was going to put like a little, electromagnetic disc on top with little coin batteries. But this right here is the next one. And for some reason, the cubes don't want to fire. I only got the cubes to work once on this. So they do work, but it's like a pain in the butt. So what I did was I made the rotor is that 120 big square magnet rotor. So that'll work out. That'll be fun. And it'll be a 0-1 or an on-off pulse motor at 180 degrees. That's just how a 120 and a 180, wind up. And whenever one's on, the other one will be off. And then whenever the one's off, the other one will be on. So it's like, it's on all the time. It's weird. but it's never on. The torque is never very high on this one at all because only one magnet is ever active at a time. It just happens more repetitively in a faster pace. Now with these big coils, I had it working on 120 on 120, and it would hit 3 magnets every time, 3 on 3, and that's about as much torque as you can get. Um, being proportionate. Now, being non-proportionate, I'm pretty sure you could get more. But as for these motors, they're not renowned for torque. There's some axial flux designs that have, greater amount of torque, and there's some many more coils than what I work with. I work with like up to a 9 at the most throughout my entire YouTube. And if you do 24 coils, each with the core, you're going to get a tremendous amount of torque. Because that's going to be each one of those popping at the same time. You add up all the force, and that's awesome. All right. So, wow, I feel like I want to put the other kind of rotator on here just to see how well it's going to spin. I might have to dismantle that one. I need one bearing. I don't have enough bearings for all the rotors that I have now. I mean, I used to work on a 1/4 inch shaft. So I have a lot of stuff on a 1/4 inch, but this is 10 millimeters. That's not a 1/4 inch. So all that stuff, I have to build another 1/4 inch table. I love that table though, man. That table was awesome. And I love how all this stuff can just easily dismantle and assemble. I don't know, with the maglev it might work. Anyway, I'm not gonna run it with power. I'm just yeah, it needs a bearing, it looks like. So the bottom one is going to be magleved, and that's good. And then the top one is going to rest on this. Oh man, I need to buy another bearing. I mean, I can't just keep on swapping them out. Yeah. And I will eventually. I mean, when the money rolls in, if the money rolls in, I'll buy another bearing. And I've cracked 2 of them. And that's over the entire duration of me doing this. It sucks when they break because Yeah, and it's really easy for them to break too. All right, so these are full ceramic bearings. And you can see how well they spin. These are hybrid bearings that have one of the balls removed intentionally. So this is maglev. There's a magnet in the middle of this big thing, and it's holding this up. And those hybrid bearings are way better. They're way good. If your magnetic flux is that temperamental, then you might need to redo your whole thing, because you know as you can see here, there's like no problem. There's 3 of these huge needles just pounding magnetism at it, but it's all equal on all sides that it's being affected on. And that's why I think it's not really an issue to begin with, because it's being affected equally on all sides. So it's kind of like it's not even there. Now I'm talking about the magnetism between my neos or even my electromagnets and the steel bearings in the center, which has got ceramic balls and steel bearings or steel casing. They're really, really good, man. I mean, it's unbelievable, in my opinion. And then, of course, the full ceramics are awesome. See, look at the lights light up. That's awesome, man. The power is off and the lights are lighting up. That's a win. Here, let's turn this off real quick. You can see it better. All right, so that is so cool, man. So without power, you get a little bit of light, but with power, you get the proximity transformer action going on. What is a proximity transformer action? What does that mean? When you turn them on, you can see the power surge when you turn them on. Is that when you hear a chirp, you get a burst of power through the pickup system. See how much brighter it is? Because it's like you're getting it straight from the battery through proximity to the pickup coil. So like these little things are things that I know just from putting lights on it. You know, since I can't get a legit reading off of it, I might as well try and get as much information as I can. Because frankly, all the other stuff I'm doing is boring. That's why I'm doing this, because this is exciting, it's different, it's new, it's hard, it's challenging. Everybody's asking me, so how many watts does it produce? And I'm like, yeah, that's a great question. And I'm not sure that's going to be its purpose, but I mean, it'll be part of its purpose. Now there's originally 6 neos on this. I can make it 6. That'd be going pretty fast with 6 nanos. I think it's syncing up. What's awesome is that if you use an Arduino, when it syncs up, you get more crisp math that you can use because they're both going at the same speed. Because I heard that the math to do a counter rotator with Arduino is extremely difficult to pinpoint the timing. So of course, in order to fix that, you got to have them sync up, and you got to know how fast each one is going. And when they're going the same speed and they increase and decrease at the same speed, then you know you're synced up. And well, that means is that they'll start to increase in speed because there's no way to decrease the speed except for using my finger or a piece of wood or something. You know, it's basically the same principle. I feel more comfortable using my finger until we, like I said, we're going to go SSR for the trip, and then the IR trigger for the SSR, which will be the on-off switch, the SSR, which will be great. If I can cut the power on this thing, that'll be this last step. That'll be awesome. All right. I just love how close everything is to being like together. Of course, the rotor is resting way too high. And the reason it is because I made a spot for the maglev. I made a spot for take that spot away. Yeah, I don't know, man, because with the maglevs, you got a lot less control over how high your thing is going to be. You know, using something like this, you got total control over how high it's going to be. Like you got total control if you use this. You use the maglev, you're at the strength, you're at the mercy of the strength of the magnetism. I wish I had more of those. I'm sure I do somewhere. It's just my stuff is like everywhere now. All right, so I love it, man. The lights are just lighting up. Some are lighting up brighter than others because the different colors have different requirements. Like red is bright, orange is bright. Some of them aren't even lighting up now. See, so they're all different. And then when you counter rotate them, they get even brighter. Oh man. And it's like the untethering of the stator was basically a bet, kind of like a bet, like, you know, if you make it so the coils spin instead of the electromagnets, you can make a time machine, was what it was, you know, presented to me. And then I was like, well, what if I have the outside, what if I make it a counter rotator? Because it's all about how fast it moves and how it interacts with the environment. So when the coils are popping on and off, as they go around. I mean, they might already have all the juice in them already, but they're popping on and off. The on and off, the 0, 1. The stuff just doesn't go away because we've discovered something new. Okay? At least not yet. So this is the best way to explain this. When it's on, you're 1, and then when it's off, it's 0. And that's why I explained it as 0, 1 pulse motor, because the amount of, you either got 1 or you got 2 coils on the rotor. And then the external is either going to be 2, 3, or 6 electromags. Yeah, and that's it right there, man. When the electromagnets pop and they're interacting with the atmosphere around the coil, right? But they're pulsing on and off as they spin. Now that effect is probably what everybody is talking about, and that's not under my control. Okay, even if I had like all the bells and whistles on this thing, that occurrence is natural. The fact that this thing counter rotates is natural. 100%. Like it is. Every time, without fail. Yeah, I could see that getting really, really fast, really, really quickly. But it's way too high on the shaft for me to just let it run. I mean, this is the top of the shaft right here, and it goes all the way. It touches the table underneath the table. So this is like 2 feet up here, up above. So I think it's really well balanced, if you ask me. So it's a little displeasing to the eye. It might be a little crooked in some places, but as for balance, not the best. But I think it's good. You know, it's probably going to be rebuilt, 3 or 4 more times. But again, I like the fact that I can make these lights turn on without actually turning the power on. So I mean, when you say that there's not being any power generated, where's this power coming from? I mean, it's probably already there, but you need something to unlock it, right? Which is the magnetism. But without the magnet, or without a trigger of some kind, that power remains locked and undetectable. So the magnet is pretty key in that equation. And then, I mean, I just wish that we could all sit down and talk plainly, because I'm trying to keep up with everybody and what they're doing and what they're trying to, the messages they're trying to put forth, and it's See, I'm not an engineer. I am not an electrician. I do not know the lingo front to back. Okay. So, I'm still, I mean, the farthest I've gotten in communication wise was with chat this morning. And I'm like, hey, how do we stop this thing? Yeah. Mm. But I think having all these 20 gauge coils is also pretty fun too. Because I can run yeah, man, there's so much stuff to do. And it's like, the mixed reviews that I'm getting on this particularly is interesting to me. That there's a sect where people are like, and these are like the engineers and the electricians, and they're like, where's your schematic? What's its purpose? And maybe it's like the left brain people, all that stuff. And it's like, well, yet to be determined. I mean, you can make attachments for it. You saw how fast it can spin, so this thing could probably fly under the right conditions. Uh, there's many applications for it. There's more applications for this than there is for an AR. Just let's put it that way. I mean, I can see maybe 2 legitimate uses. And maybe I'm wrong, because there might not even be one legitimate use for this other than to, satisfy my curiosity as to what it will do. Because I do believe that having the electromagnets be the part of the thing that's actually, spinning is phenomenal, man. It's great. Mm. So the way this is made up, there are 8 coils on this thing. There are 4 drive coils and 4 pickup coils underneath them. The pickup coils are hooked up in series. So every time one of the drive coils hits, you get that transformer action going on the whole pickup system. So, and right now it's just one end of it's hooked up. They're just hooked up to these 7 LEDs. Because if I don't even know what its purpose is, I'm not going to have, and then if you put anything on there, like a battery charger or anything like that, you have to balance it out because it's going to be spinning. Whatever you put on there is going to be moving. Okay, it's not like you can just add it and it's going to be okay, because if you add it, normally you should add 2 to balance it, maybe 3 if you're going to perfectly balance it. Use a triangle. Doesn't matter what the other shape is. I'm pretty sure that 120 weight is going to balance it out pretty good. Oh, yeah, that would be great and just so cool. Now, I had an idea. So that we could move along. And that's to add this ribbon of plastic right here. Right? Or a ribbon of plastic. We might even make it clear. I'm not sure. And then we put the cone on top of that. Right? again, like all prototype-ish, but you can kind of see it spinning in there and work out nice. Or we put a piece of like acrylic or plexiglass just on the top there and not have it be a neutron shape. Can't. The music isn't working?
I want my music back, but Caleb's using my phone right now. So I can't listen to Spotify.
Yeah.
My song was so good too. Yeah. Now I'm bored. I still want to edit, but like I'm bored.
Yeah, well.
I can't make any thumbnails. I've been doing descriptions for the past 5 minutes. Well, no. But what I've been doing. If you have questions, put in the descriptions. I don't know.
Oh, that feels good. To sit down for a second.
Yeah.
So yeah, I think this idea for the outer rim is going to work out just fine. I might because when the outer shell is on, and then it's just this shape, and when you spin it, and it starts spinning, faster and faster, and you can't really figure out why, but there's something in the middle doing it. It'll be great. It'll be great. And then they have that remote. You need the remote or you can't even add this stuff to it. So the way it was described to me, it's going to be pretty easy to do. Does this have its magnet on it? Yeah. All right. See, I printed off another base, but this one is, the center hole like broke. You can see how it's broken in here. So you can't put a bearing in it. So it won't be able to spin, but that means it's a solid state one. It's solid. So we'll run it with this for a minute. Oh yeah. I hope that those two magnets are enough to levitate this because I don't want to glue it in. So I don't know if that's right. All right, so that is not glued on there, but that's okay. See, this one was supposed to be the one, man. Like, I cut off the bottom of the Utron, made it like a saucer.
What is he making? Well, not a bomb, not a time machine, not anything wacky, but just like a motor that can, I suppose, create power. It can light up lights, light bulbs.
It spins.
It spins. That's probably an old question.
Yeah.
All right.
All right, let me see. These are all facing the right way. North, north, north. I bet that would get going really fast as well. But even if we stopped it like this and one of them was stationary, you still wouldn't be able to get the data that you need unless you program something to get it for you and put it in there. Woohoo! Alright, let's turn it down. Of course, it would still probably take a while to slow down, but again, that's awesome too. From the print that didn't succeed, I made something that is successful. Thank goodness. And that's the other thing about the left-brained. I think it's left-brained people. They always they always know, like they do it all what I consider to be backwards. They all know everything before they get started, and that's an awesome way to do it. I'm probably going to learn myself how to do it that way myself. But you know, if I did do that, this would have never been made at all, because it is posing quite the challenge. So much of a challenge, I believe, that people would say it's not worth it. But I still built it, and whoever's got ideas, feel free to put them forth. It's pretty simple, honestly. You've got just your basic MPN circuit, 1, 2, 3, a base connection, a collector connection, and then 3 emitter connections. You need 2 collector connections, 3 emitter connections, and 1 base connection to make what I believe to be the simplest MPN motor circuit that you can build. And it's basically for a trigger coil. You don't need to use a trigger coil though. You can use your Hall effect sensor, your reed switch. You can use both, your Hall effect sensor and your transistor. Well, your transistor's got to be there no matter what. And your Hall effect sensor or your reed switch or your trigger strand. Those are your 3 basic ones. And then you got like a spark gap, which I still don't know much about. It's like, and then the piezos. I mean, you got 150,000 different ones you can choose from. So it's like, okay, whatever. You know, that's how I feel about it. It's maybe there's somewhere I can get the data I'm looking for, because it's like, is it really called a spark gap or is it a spark plug? Because spark plug I know a lot about, not hard. The spark gap, I type that into Amazon and I get nothing except spark plugs. I wonder why that is. Maybe I need a business account or something. I don't know. So I really don't have, other than getting the infrared SSR on there, I really don't have any other things that I'm working on right now. But we see so much of this because I really want to see if it is, usable.
Mm-hmm. I'm just reading through because,
What's up?
Do you want me to read them out loud?
Yeah, I guess.
Okay. This was, I don't know how long ago these comments were because I'm not paying attention. Alright, he's making a motor. Is that a phase 2, Jenny? Balance is off. Might want to add some equivalent weight to the other side so it's not so wobbly. Good idea. Why, NPN, PNP would be better to diagnose and fix if you had issues. Spark gap is the gap between the plug diodes. I don't really know this very well.
No, I don't want to know what it is. I don't care what it is. I want to know what it's called so I can get one. I don't really care about all that. Just I want to try to use one, and I don't know how to find it. The one that I'm supposed to use. And then, God, what's that other thing? The spark gap. Oh no. Getting tired. But yeah, like a spark gap, I could work that into the system. The piezos. That's the other one, man. I mean, God, I got two different kinds right here. They're both wrong. Yeah, so I don't know, man. They're on another level that I don't even want to mess with because it's not, requires more frontal lobe activity than I got going on right now. It would be great if somebody could just send me a link. That would be awesome.
Kitty.
And then I'm gonna get some some welding rods for core material.
It's dependent on the voltage and the metal for the electric charge to gap the electrode.
Yay. All right. So yeah, I get it. That there's different ways that it works, but I can't even start to think about how it works until I actually get one. So that's the problem I'm having, is getting the right one that is applicable to what I'm doing and not doesn't belong in a sedan somewhere.
Mm-hmm.
Have you seen my screwdriver case anywhere? No?
What one?
The black one.
No.
Oh man, I'll have to find that because I have the screwdriver in my hand right now, but all the bits are floating around somewhere. See, but I'll have to have two. Two SSRs and maybe one remote that has two channels for infrared. Huh. All right. Well. A couple experiments that I want to do. I'm going to use my signal generator, and I'm going to get my iron filings. I'm probably going to put them inside a glass jar or something like that, and we're going to scope out, what the magnetic field looks like in 3D. That'll be fun. All right. What's up, Mike? So did you hear I'm going to use an SSR to turn this off remotely? That's going to be awesome. That was pretty stable. I think that was good. That was a good run. I didn't have to touch it barely at all. Look at how much shaft we have on this design and from the other one. That so the lower center of gravity, I believe, helps out a lot in stability. And I don't think that this rotor here is wobbly or tiltish in any way, really. It's not. It might be like the weight, the two batteries that are in the center might be a little off. And if we, can be sure about that, we could fix that, like you said, with put a 9-volt battery in there. You don't want to put any magnets in there. You don't want to put any steel in there. You don't want to put any, with your heaviness has got to be, an alkaline battery is going to be bad too. I mean, maybe some glue. No, it's not. This rotor right here is not the problem with the other situation. The print was bad and no amount of weight's going to fix that.
I'll be back later.
You coming back later?
Later.
All right.
All right. See ya.
See ya. Yeah. Okay, so there's where weight problem kicks in and then it goes away. Kinda. So I remember Joe saying something about that. That if it gets spinning fast enough that the differential will disappear, kind of. Wow, it's making me excited, kind of. It's probably going to take 3 weeks to get it done, but I got a plan now. GFC certified or something like that. uh, it's self-contained. Self-contained. Oh man, I love it. I love it, man. It's like it just came together. Oh, that's so smooth. Just moving that back and forth. That bearing is so nice. So there is a little bit of a weight problem. It's really small though, I think. Mm. It's a hybrid bearing, ceramic and steel. They didn't have any of the skater bearings big enough. They were the wrong size. You're supposed to go 280,000 RPMs though, or 28,000. You know, like Griff's freaking chicken sound from Back to the Future 2. I always remember the way that guy clucked, man, because it was like, mechanical, sounded like a chicken, or what you thought a chicken might sound like back in the day. Yeah, man. Guy with the bat. Oh yeah, way stronger with two motors. I don't want to let that one get away, dude. That might hurt my finger. mm. All right, all right. We're gonna change the pace here, man. I gotta sit down, so I'm gonna bring this over and engage for a minute. What's up, son? Oh man. Oh, I already made one out of duct tape. This one actually has Teflon on it. It looks like it's about to snap. No, the second one where they're in the future, Griff. Well, it's the Spankatron 9000. And when you hook the little rubber hand up to each one of the coil nodes and you turn it on, you can discipline people with it, or animals, or I don't even know. That's wrong. It's all wrong. So simply, the concept is that you can attach what you need, what the use would be to it, and what it does is it does what a rotor does, and that's spin. That's all a rotor really does. So in this raw form, that's all it's going to do. Um, but you could attach propellers, and it'd be a 90-degree propeller blades. Yeah, the Spankatron 9000. Well, hey, man, if that's what you're into, you just, what is it, TFU or something? The printer filament that's all kind of rubbery and stuff. Print yourself out of hand, attach it. See, that's the thing, though, man. You got to be some sort of magical engineer to attach something to this and have it be spinning. You have to rebuild it to incorporate that into it in order to do it safely. You can't just nail it on there. Yeah, heck yeah. They're like, what is this? What is it? Like, can I take it? And then you just turn the IR SSR on, and it'll turn on. And then, well, actually, I don't know about that. I know that you can turn it off that way, or you'll be able to shortly. But as for turning it on, you have to spin it at this point in time. You gotta, because it's run off a trigger coil, so you have to spin it. Now, see, the next rotor could have a spot for a Hall effect sensor, and then I wouldn't have to spin it, and it might even be able to start, on its own in that regard, with if you have the positioning right. And you could probably set it up so that it's right every time. Um, yeah, that's what I'm talking about right now. It's going to be an infrared remote infrared trigger for an SSR, a solid state relay, which will cut the power. And then you could turn it, you could reconnect the power the same way, but you still have to spin it to start it. Mind power. That's awesome. Yeah, make it magic, dude. That's how we got to do it. Nah, I got to do something that works, and I got to do it quick. So I thought that mind crap only worked on people. And you can see it right here. The coils are here, 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 and here. And so when the coil that is on, none of the other coils are lined up. And so that's the doing the 120 and the 90-degree coils. And in this case, it's 180, but there are the other two that are dormant. So it is 90 degrees. You will always only have that one magnet working at a time. It's amazing. And if you like, yeah, it's just cool. I think it's manageable. If you got to stop it with your finger and only have one coil active at a time. Yeah, yeah, that's cool too. Bluetooth. I was thinking, I mean, honestly, to use an Arduino, my bad, and program this thing to go about 300 RPMs. But he said that the original bass moves. Okay, this thing spins. This one doesn't, but you get what I'm saying. It spins, so it's a lot harder to figure out that math when they're both spinning, especially in opposite directions. What? Oh, with pads? Okay. I mean, it seems like a great idea, but putting that in there is going to set my rotor off balance, isn't it? Not the 555 timer, but the oh, okay. No, it's very small. Yeah, I could probably I have no idea how to use a 555 timer either. Well, it's not going to affect the coils in any way if it's on the case. All right. Yeah, no problem. I know how to use Google. It's just chat, it's conversation. But, the 555 timer, that was a suggestion to control the speed, but that doesn't control the power. So, what ideas do we have for the power? Like, are we going to, I think infrared SSR is going to be a good idea for that. Oh, I see what you're saying. Yeah. So it's got to be on the inside of the hole there that the thing is sitting in, on the case side and the shell side. I get it. Yeah, it sounds familiar. You're gonna want this, and this. None of that stuff is gonna fit in there. Um, Maybe actually, when I take that black plate up, there's a black plate where all this stuff is sitting on there, and the batteries are in a box underneath that. There's a lot of room in there to yeah, especially if it's all going to be wirelessly controlled, and that's what it needs to be. And I think we just need to start by working with the power. Oh yeah, this is a teeny circuit too, man. This is seriously, it's just a 1, 2, 3. One base connection, um, two collector connections, and three emitter connections for each one. It's so simple. Oh, the clips? I know, man. I have to glue them down every time I move them around. That doesn't mean anything, dude. With the last comment you just made, make sure you get better connectors. What does that even mean? What does it mean? I mean, you can't just say that and then say be safe. You can't say that. What connectors are you talking about? I know these ones. You said I gotta get different ones, better ones. Which ones are they? I don't understand. These are like, which ones are you suggesting? All right, dude, I don't solder. So all your teeny connection, all your teeny circuits are actually pretty big hassle for me because I don't solder. Yeah, man. That's why I have the clips in the first place and the breadboards because believe me, man, if I soldered, I'm 45, I've never soldered a damn in my life. I've got a soldering kit right there. And I want to try, but I got nowhere to do it at that makes any kind of sense for me. I shake like a lot. So doing things that require my hand to be still are not my strong suit. All right, man, believe me, I'd be soldering crap all the time. Because I know it's like the best and cleanest connection you can make. So the question to chat was like, so how do I build one of these things without solder? Nah, man. There's always another way. But yeah, I'd say the safest way would probably be solder and then probably a PCB board for all the components. Um, I had somebody on TikTok offer to make me one. He's like, dude, you need one of these. I'll be like, yeah, I do, no doubt. Oh, you mean from the force? Well, I can't do that. And everything, see, this is the thing, man. There's no schematic for this. This is an evolving monster. So, it is, there's no schematic. So there's no need to be permanent about any of this stuff because it's going to change. That's why. And it's like if you solder it in there, and I've thought about this a lot, if you solder it in there, um, then you have to unsolder it you got to solder it again to get it out. You got to melt the solder to remove it. And I guess it's pretty simple. I'd love to learn how to do it. Oh yeah, that sounds like Star Trek, man. It's like, yeah, the warp drive equation that lets you jump from ship to ship in warp speed. You just haven't thought of it yet. That's awesome. Man, that's awesome. Thank you. Yeah, I'll probably end up writing it down. And the fact that these things kind of rotate is natural. No, I would say there's a lot of steps that need to be taken before this can do it like work. But yeah, if you attach the rubber hand to the node right here, and you turn it on, and it'll smack you really hard, really fast. And the Spankatron 9000. Yeah. Slapmaster 1. What's up, Kevin? All right. So this base is stationary, and I believe that Arduino calculations can be made easier with the stationary, one of them being stationary at least. See, but can you imagine, like you spin the outside shell, right? And then this thing starts spinning in the middle. And yeah, you can start the inner part by spinning the outer part, for sure. And then it just starts spinning faster and faster, and being in a safe environment, of course, like outside. And then, of course, like speed control, 555 timer, won't ever get too fast. And then you'll have your emergency off switch, which would be wireless, for sure. It's got to be a wireless off switch. And then, yeah, that would freak people out, man. I'd be like, "What's going on? Why isn't it stopping?" And or like, of course, a lot of people will know that there's something in there. Yeah. It is the brake pad currently. Thanks, Kevin. Appreciate that. Now, this is the radial flux design, and I have an axial flux design that I'm currently working on. It's going to be really cool. All right, so I want to switch this stator. Sorry, this stator for the stator that spins. Or I want to make a new stator that's like the one that's up there right now that spins. Because then we'll be that much closer to actually getting a cap on it. So we got ceramic bearings in here. This one's a lot lighter than that one. It's a lot lighter. And the wobbliness is in the print is warped. So it's not like something I can correct. Gotta print another one that's better. But it's basically the same design. Boom. 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 Okay, now I'm going to put the other 3 in there. Actually, I need to put, where's my, there it is. Put that maglev in there, and it's like it spins forever. You can imagine how this one's gonna go. It's all kinds of wobbly. It's not wobbly, but it's crooked. You know, wobbly is the wrong word. Because it's spinning like it's not wobbly, but it's crooked. All right, now we're going to put our rotor back on. All right. Oh yeah. Woo! That's pretty strong. Now, can that like do that with a sledgehammer? Probably not. I mean, not like instantaneously. I mean, if it had some momentum, I bet it could throw a sledgehammer. Yes. You can see the laws of physics being demonstrated in the counter rotator. We're going this way with the magnetism. Sometimes it just needs a little nudge, but it'll just basically fall into the counter rotating. So cool. I'm not going to turn the second one on. That would be a little too much, I think. I mean, it would get up to speed so fast that I might not be able to get my finger in there in time to turn it off. And then with the 6 in there, you got so much less space to put your finger anyway. So it's like an art form almost. I'd rather turn it off with a remote though, you know what I'm saying? So yeah, you can do this, and then when you spin the outer shell and it starts chirping and moving really fast, people are gonna freak out, but that's okay, right? Some people are gonna be like, wow, that's cool. Because it's cool. None of this stuff is rated to fly or whatever we were discussing earlier, spin. Without that tape, those things would fly right off of there. And that tape might break. And in that case, they'll fly right off of there. You know, there is risks involved with not knowing how to do stuff. That's how I would put it. At least there's no sharp, components. There's wire, that's a piercing component, but I've never been actually poked with a wire yet. Thank God, right? Um, yeah, I mean, I've actually had an axial flux rotor basically disintegrate on me while it was going at like 3,000 RPMs. It's on my birthday stream if you all want to check it out towards the end. But basically, the rotor, a magnet like pushed through the outer edge of the rotor, just broke right through the print and went flying this way, and the rotor and everything else went flying that way. 180, equal and opposite reaction to the action, and size and weight really didn't have anything to do with it. Because the rotor and all the rest of the magnets went that way, and one magnet went the other 180, and it was like, boom, it happened so fast. 3,000 RPMs is fast enough for it to happen, fast enough for you to not know what's going on. It was all my designs from that point forward changed. Everything changed from that point forward. It's now 25% or more for infill. Especially when you're making a rotor, man. You don't want, because it broke. It just sailed right out of the edge. Like it just, the print was not strong enough to handle it. And the magnet, you got to make, if you're making magnet holes, you got to make them as tight as possible. I mean, if you're planning on, moving stuff around a lot, then you want to make them so that you can, you might want to just put a loop of tape around them so that they're nice and snug. And I might even do that with these and this one because, well, see, it's all pretty. See, this one's loose. I never let this thing get very fast though. But if I wanted it to go faster, I probably would. Maybe even glue. Start thinking more permanent positioning. I think the positioning that I have for this is really good. I think, especially on this one, because you got the 2 and you got the 6 magnets on the outside. So in every 180, you got 3 180s on here. Both magnets are going to hit 3 times per rotation. before they, everyone will actually hit 6 per rotation, but before they start double hitting, it'll be 3. So before it hits the same magnet again, it'll be 3 and flip flopped. It's kind of hard for me to describe it, but with the 6 magnets on the outside, you get a 180 configuration for the neos as well as the electromag. So every 180, there's 2 thrusts, torques every 180. Oh, I put the second motor on. That was pretty interesting. Yeah, that was a little freaky. Hello, hello. And then you got, your battery, you got your breadboard, you got your jumper wires. None of which, of course, should be spinning at high speeds. And I don't think there is a rating for, people actually do make rotors like this? Or is it always the other way around? Why? Why? It's only 12 volts. Why? Yeah, it's a 12-volt battery, dude. I guarantee you there's no fire is going to happen here. So you don't even need to mention it, bro. And why do amps matter more, dude? Why is that? Whatever you want, bro. Whatever you want. I'd say that has a lot of torque with 6 magnets, even though there's only one electromag going right now. For what it is, I wouldn't say that, like I said, it's not going to throw a sledgehammer around, but it wanted not to stop. It's that good. I already got a pickup system in here. It's not going to run it without a battery. I'm trying to work a way to do it with a capacitor, but it's probably not going to do it with a capacitor either. So I'm just keeping it real. Mm-hmm. Do you even know what that means? All right, I'm going to make sure this is off. I'm going to see if I can turn the lights on without the power being on. Here, let's turn this off. All right. No. It works with 3, though. So you got to have some spacing in between your magnets for the generation to work right. That's awesome to know that. Normally I can get those LEDs to turn on without the power with the 3 neos. But with 6 in it, there's like not enough space. It's all too much magnetism. No, dude, I already had it hooked up that way, man. It's not gonna work. I've already tried it, like with what I have on here, and the pickup coil is like, it's 4 coils of 2,222 turns of 30 gauge in series. And if that doesn't generate enough voltage slash amps to run it, then, you know, I'm getting about 300 milliamps off of this pickup coil over here, though, this black one. This one right here is totally magnetic induction. Like, by magnets passing by it, I'm getting 300 milliamps of current. That is freaking phenomenal from what I'm used to. I usually do 32 gauge coils and I get about 20 milliamps. Hmm. So I'm wondering if I should take the 3 magnets out again. I might. I'm gonna need both my hands to do that, though. Or I could go 180s. Let's do 180. So just 2 magnets in the outer edge here. All right, I'm gonna go put you guys back in the thing real quick, and I'm gonna probably wrap it up after this one. Been doing this all day. It's been fun. All right, those are good. Now, take this one, put it in there. Take this one. Oh. Maybe we'll take the other one and we'll put it right here. So now we got 180 perms and 180. This should be interesting. Nice and smooth. So the reason the lights get so bright is because of proximity transformer. All the pickup coils are right next to the drive coils. So this is both on. See, and I think when those two hit, it's the max amount of torque that this thing will have no matter how you set it up, because you got your 180 hitting on your 180, and that's as good as it gets. It might repeat itself, but that's as good as it's going to get. I don't know exactly if repeating itself is actually giving you more. It's just, maybe it is. So having it be repetitive is giving you more torque. Like if the other four magnets were in here, you'd get more torque per rotation. But if it's only up to the electromags, then it doesn't matter. You're only going to get that 180 worth of torque. Oh man. Well, I think this has been a good day. What's up? All right, I'm going to get you off of here real quick again. All right, so I'm going to just try and give this a whirl. I do want to... Yep, 2 won't do it either, but 3 will do it. All right. I think I'm going to put the 3 in there just to see it work. So we're going to do 120s. Boom. And the other one here. See? They're lit up. They're lit up brightly. And I didn't have to use the power. This is all from magnetic induction. So cool. So with 3 at 120-degree neomagnets, there's enough perfect magnetic energy to go into the 90-degree coil spread, and they're just, it's enough to light up the lights like awesomely. Too much caffeine today. But is that enough to run the system? It's not. It's a different kind of energy. Peace, Mike. So cool. Yeah. All right, so I got the plan in motion, and that's going to be it for today, folks. Thank you so much for chilling. I really appreciate everybody coming through. And I'll talk to you later. Bye now.